Assalamualaikum and hi guys. Today my friends and I want to make a presentation about infrared radiation technology, and this is our group members. My name is Aidil Adamin Azmi. My matrix number is 2023454528, and this is Aisa Amza bin Azman 2023888522, and this is Ainuddin bin Muhammad Rafi. His matrix number is 2023489684. And our last group members is Imam Muklis bin Azrul Hanidi, and his matrix number is 2023853892. Okay, hi everyone. Before we talk about how infrared is used in the real world, let's first understand what it actually is. What is infrared radiation? Infrared radiation is a type of invisible light. It's part of the electromagnetic spectrum, just like visible light, X-rays, and radio wave. But here's the cool part. Infrared light lies just beyond the red part of the visible spectrum. That's why it is called infrared, which means below red. We can't see infrared radiation with our eyes, but we can feel it as a heat. For example, when you sit near a campfire, the warmth you feel on your skin is caused by infrared radiation. The sun also gives off infrared rays, which help keeps our planet warm. So even though it's invisible, it plays a big role in our everydays in life. What is infrared radiation technology? Now that we know what infrared it is, let's talk about infrared radiation technology. Infrared radiation technology simply means using infrared light in different tools, machine our system to do useful tasks. It used in many areas like sensing heat, detecting movement, sending wireless signals, and even looking into a deep space. In simple words, infrared technology helps us to see things we can't normally see, control devices without touching them, and detect heat where it matters most, whether that is in a hospital, a telescope, or your TV remote. In summary, so to wrap it up, infrared radiation is invisible light that we can feel as a heat. Infrared radiation technology is when we use that invisible heat and light to power useful tools in science, safety, health, and everyday. And now that we understand what it is, thank you.
Bismillahirrahmanirrahim. My name is Ainuddin bin Muhammad Rafi. So in this slide, I will talk about scientific explanation of infrared radiation. So, the first, infrared radiation is a type of electromagnetic wave with wavelengths between 0.7 and 1000 micrometers. It lies just beyond the red part of the visible spectrum, which is why we can see it with the naked eye. All objects emit infrared radiation as long as their temperature is above absolute zero, which is minus 273.15 degrees Celsius. This process is called blackbody radiation. The hotter an object is, the more infrared energy it gives off, and the shorter the wavelength of the energy. Infrared sensors detect this radiation by absorbing the IR wave and converting them into electrical signals. These signals are then processed to produce temperature data or thermal image. One of the most common components used in infrared system is called a microbolometer. It's a tiny sensor that changes its electrical resistance when heated by infrared radiation, and this change is measured to determine temperature. One major advantage of infrared radiation is that it can pass through obstacles like smoke, fog, and darkness. That's why it's used in applications such as night vision, fire detection, and thermal imaging in low visibility conditions.
Now we are going to talk about scientific principle in infrared radiation. So there are few of principles that need to be considered in infrared radiation. First of all, Planck's law to describe how objects emit radiation. Next, Stephen Boltzmann law. The total infrared radiation is infinite to a temperature. Lastly, Wind law. The hotter object emit, the shorter infrared radiation. So, why this principle matter? This scientific law help engineers design infrared sensors that can detect small differences in temperature. That's the reason why thermal cameras can see heat even in total darkness. So in short, the scientific principle behind infrared radiation like Planck's law, Stephen Boltzmann law and Wind law help us understand how heat become visible using technology. So there are a few of key instruments in infrared radiation. For example, infrared sensors to detect incoming infrared radiation. Next, infrared radiation cameras to convert heat into visible image. And then infrared radiation spectrometers to analyze how materials absorbs. And then lastly, infrared radiation laser to emit specific infrared radiation like for remote or therapy. From motion sensors to thermal cameras and lasers, this infrared instrument help us to see the invisible. This turning heat into useful data in medicine, industry, and everyday life.
Okay, let's talk about example of real-world implementation. Okay, I'm going to share something really fascinating about infrared radiation technology. Even though we can't see infrared light with our eyes, it's all around us. It travels just beyond the red parts of the visible light spectrum and shows up as heat. From space telescope to the simple TV remotes, infrared technology is quietly working behind the scenes, making life smarter, safer, and more connected. Let's explore how this invisible light is used in the real world. First is thermal imaging or night vision cameras. Let's start with the thermal imaging, also known as night vision. These cameras don't need light to see, they detect heat. This means they can see in total darkness by picking up the infrared radiation coming off people, animals, or objects. They are used by soldiers during night missions, firefighters looking for people through thick smoke, and wildlife researchers who want to study about animals at night without disturbing them. So the cameras turns heat into colorful image where warmer things show up in a red, yellow, and cooler things in a blue or purple. It's like turning heat into vision. The second is motion sensors for security. Next, let's talk about motion sensors, especially the ones used in the security system. These use infrared to detect changes in heat. So when someone walks past, even in the dark, the sensor pick up their body heat and sends a signal. This might turn on a light, sounds an alarm, or sends a security alert. You have probably experienced it. Ever walk into the room and the lights turn on automatically? That's infrared working silently in the background. It's a simple, powerful way to keep places safe. Third is infrared space telescope. Now let's go to the space where infrared is helping us see the invisible. Space telescope like the James Webb Space Telescope use infrared to look at stars and galaxies. Why infrared? Because it can see through dust clouds and detect things that don't shine in visible light, like faint stars or distant planets. With infrared, scientists can study how galaxies are born, discover new planets, and even look back in the time to early universe. Without infrared, many parts of the space would still be hidden from us. Okay, fourth is satellites monitoring Earth. Still in the sky, let's look at the satellites that orbit Earth. They use infrared sensors to study our planet 24/7. These satellites can measure land and sea temperatures, detect wildfires, monitor storms and weather. and track changes in the climate. Infrared helps scientists and governments respond faster to the natural disaster, protect the environment, and understand global warming better. It's like Earth has its own thermal cameras in space. Number 5 is medical thermometers. Back down on Earth, you have probably seen or used an infrared thermometers, especially during the COVID-19 pandemic. These devices measure body temperature by sensing the heat coming from your forehead or ear without even touching your skin. They are quick, safe, and clean. That's why hospitals, clinics, and schools, and also airports use them so often. It's one of the easiest and most practical uses of infrared in healthcare. And the last is remote controls, TV and air conditioner. And finally, something we all use at home, remote controls. When you press a button on your TV or aircon remote, it sends an infrared light signal to the device. Even though we can't see it, the device understands the command, whether it is changing the channel or adjusting the temperature. Infrared makes it possible to control devices wirelessly without any cables or touch. It's small things, but it makes life more convenient every day. Okay, so for the conclusion is, so from helping firefighters and scientists to making our homes and hospitals smarter, infrared radiation technology is all around us. It helps us to see in the dark, stay safe, study space, protect Earth, and check our health, and also relax at home. It may be invisible, but its impact is huge. Thanks so much for listening.
Next, potential benefits. First, non-destructive testing. IR can detect faults in material or structures without damaging them. It also widely used in building inspection and electrical maintenance. Second, night vision and surveillance. IR enables visibility in low light or completely darkness. It is also useful for military security and wildlife monitoring. Third, medical applications. IR thermography can detect abnormal heat patterns in the human body, example, inflammation and tumors. Now let's move into the challenges. First is limited penetration. IR cannot penetrate through glass, water, or thick walls effectively. It also limits its use in certain environments or materials. Second, high initial cost. High quality IR sensors and camera may be expensive. This may be a barrier for small businesses or low-budget applications. Third, required skill interpretation. Thermal images often need expert analysis to interpret correctly. Misinterpretation can lead into the incorrect conclusions.
In this slide, we will talk about future development of infrared technology. Infrared technology is becoming more compact and affordable as the demand for smart and wearable devices grows. In the near future, we will see more IR sensors being built into everyday items like smartphones, watches, and even home appliances. These devices can monitor things like our body temperature, breathing, or energy usage without needing contact. New materials such as graphene or better production methods are helping reduce the size and cost of IR components. This means infrared will no longer just be used in industry or defense, but also in daily life. So for now, we will talk about innovations in infrared technology. Many new innovations are changing how infrared technology is used. For example, artificial intelligence is being combined with infrared systems to automatically analyze thermal images and detect problems in real time. This is especially useful in hospitals and security systems. Also, sensor quality has improved as they are now more sensitive and accurate than before. In this medical world, infrared is helping doctors detect early signs or illness like cancer or infections without needing to do surgery or blood tests. Some researchers are even building wearable infrared patches that can track your health continuously. This innovation show how infrared is evolving beyond what we thought was possible.
In conclusion, infrared radiation technology provides powerful benefit in surveillance, medicine, industry, and environmental monitoring. It enables non-contact, non-destructive detection and works effectively in low-light conditions. However, it faces challenges such as high cost, limited penetration, and sensitivity to environmental factors. But with proper use and expertise, IR technology remains a crucial tool across many modern applications. So this is our references and source that we used for our research in this presentation. That's all from us. Thank you.